This is video 3 of your Unit 3 Pre-Cal review. We'll pick up with question 11 here in the third video. Find the exact values of the cosecant and tangent of 210 degrees. So this is kind of spiraling in our last unit, Unit 2, still basic trigonometry though. So 210 degrees in standard position, remember 0 starts here, 90, 180, 270 here. So 210 would be down here like this. And this is 180, so 210 minus 180 is 30 degrees. So our reference angle there is 30 degrees. So we have a 30, 60, 90 triangle here. And the ratios for that were the 30 degree side was 1, this would have to be 60 degrees. The 60 degree side was square root of 3 and the hypotenuse was 2. So here is our triangle, and based on the quadrant being in quadrant 3 here, both of those would be negative. So x, y, and r is what we're using here. So x is negative square root of 3, y is negative 1, r is positive 2. So cosecant of 210 degrees, fix that, there we go. Cosecant of 210. Cosecant was defined as the reciprocal of sine, so it would be r over y. So for us that's 2 over negative 1, so negative 2. And tangent of 210 degrees, in terms of x, y, and r, it was y over x, so it would be negative 1 over negative square root of 3. So we would fix that, and these two negatives cancel. We would want to multiply by square root of 3 over square root of 3 here to rationalize that denominator. So we would get square root of 3 over 3, and that is the question 11 all done. Question 12, solve triangle ABC where A is 20, B is 32, A is 12. So they do not tell us specifically that it's a right triangle, and if you look at these angles here, they're so small that there's no way that this is has a 90 degree angle as a third angle. It's got to be bigger than that. So with all of that said, we know that we have a non-right triangle here, so we're going to have to use either law of sines or law of cosines to solve it. So I'll draw the triangle this way. Remember, within reason, it doesn't matter how you draw the triangle. It doesn't matter how you start your labeling, as long as once you've got this much of it established, you fill in the information correctly. So angle A is 20 degrees. Angle B is 32 degrees, and side A is 12. So we can find angle C by subtracting those other two angles from 180. So that's the easiest way to do that, and that would be 128 degrees. So there's all three angles done. Now we need the other side. So I can set up the law of sines here because I have a sine pair right here that go together. So sine of 20 degrees over the side that goes with it, 12, so these go together, is equal to, at this point it doesn't matter which one I find, I'll just find B first. So sine of angle B, which is 32 degrees, over side length B. So cross multiply and divide. You should be used to cross multiplying and dividing by now. And when you do that, you get B is equal to 12 sine of 32 degrees all over sine 20. And we'll put that in our calculator. Remember, on a lot of these, it's easier if you'll put the fraction button, use the fraction button, 12 sine 32. That way you don't have to worry about all the parentheses. So I definitely recommend you do that. Sine 20, so 18 point, we'll round to one decimal place, 18.6. For this side, we'll use the same setup to find C, only we'll change that to 128 and that to C. So I'll keep that same ratio, sine 20 over 12, keep that one. It's always more efficient if you'll use the same one each time. It just makes it easier for your calculator. So that'd be sine 128 all over C. So little c is equal to 12 sine 128 all over sine of 20. So what I mean is, about your calculator, what I was saying before, if you keep the same ratio, if you use it both times here, then your calculator, you can copy that down and it's almost ready to go. All you need to do is change this one angle in the numerator from 32 to 128, hit enter, and you're done. You don't have to type it all again. And you get 27, around 27.6. So all three sides are identified, all three angles are identified, that triangle is solved. Okay, problem 13, solve triangle ABC where A is 56, B is 9, A is 21. They don't tell us it's a right triangle, so most likely it's not. We'll sketch our triangle here and label it to start. So we'll label it like this, ABC. A is 56 degrees, B is 9, and A is 21. So we can use law of sines here. That's the most appropriate because we have a sine pair that goes together. So sine of 56 degrees over side length 21 is equal to, we'll need to find this angle next because we have the side that goes with it. So sine of angle B over 9, cross multiply and divide. We get sine of angle B is equal to 9 sine 56 degrees over 21. So that means B is the inverse sine of all of that, 9 sine 56 all over 21. And that is an S, not a 5. So sine inverse alpha y equals enter. 9 sine 56 all over 21 gives us angle B is 20.81 degrees. So 20.81. Now, if you recall, this is an ambiguous case of the sine law here because we found an angle measure with the sine law. So that means angle B is 20.81 degrees or 180 minus that. 180 minus second answer. So we'll have two triangles to solve. 159.2 degrees is the other possibility. So we'll solve this triangle and then we'll have to redo it using angle B as 159.2 degrees. So let's finish this one first. 180 subtract 56 subtract 20.81 gives us this third angle right here, 103.2 degrees. And then we can find this side length using law of sines again. Remember what I said before, keep the same ratio to begin with. It makes your work easier. Sine 56 over 21 equals sine of 103.2 over side length C. So side length C is 21 sine of 103.2 degrees, all divided by sine of 56 degrees. So we have... actually, that's not going to help this time. So we're going to have to type it all in. So let's do it this way. 21 sine 103.2. Divide that by sine 56. So without using the fraction button, that's how you could do it. 24.6. So that's one solution. Now we'll solve the same triangle, only changing that one angle, changing angle B. So A was 56 degrees, that was given. Side B, let's label it A, B, C. Side B was 9, side A was 21. So that's all given, so that stays the same. And angle B would be this 159.2. So angle C is 180 minus 56 minus 159.2. And that would be negative 35.2. So what does that tell you? That tells you that this triangle can't exist. You can't have a negative angle. So we actually only have one possible solution for this one. We had to check this angle, but it didn't work out. So we reject that triangle. It's impossible. And just accept this one. So we just had that one solution there. All right, let's look at question 14 next. Okay, problem 14. What is the component of the vector of magnitude 86 and bearing south 41 east in the east direction? All right, so we'll draw a coordinate plane here. and label our directions. And then it's south and east, so it'd be back this direction, and this angle would be the 41 degrees. So we'll make our triangle like this, and that means this angle would be 49 degrees inside the triangle. 90 minus 41, 49 degrees. And then the vector x component would be here, the vector y component would be here. So they tell us that it has magnitude 86, that would be the hypotenuse. So we'll set it up this way. We have the hypotenuse, we want the adjacent side from the 49 degree angle, so that'd be cosine. Cosine of 49 degrees is equal to v sub x all over hypotenuse 86. So v sub x is 86 cosine 49 degrees. So let's put that in our calculator, and we get the east direction is 56.42. So that would be the answer right there. We don't even have to find this part because the component they wanted was in the east direction, and that answers it. So that's it for this video. That's it for the review. Realize that we did not work any using the law of cosines, but you're still responsible for that on the test, so make sure you look over that as well. All right, that's it for this one.